Hi, this is Jeremy, and in this video, I'm going to go through the critical region / rejection region method and the p-value method for example 1 out of the 10.2 and 10.3 slides. And so what's going on in this section is that we're learning about how to compare means from two different groups. And while we have a z-test available, it's very unrealistic that we would use that in applications, so we're focusing on the t-test. The question will always be, are we looking at independent samples? Are we looking at dependent samples? And then should we pool or not pool the standard deviation? So looking at this problem, the question stated right up front, does the evidence support there's a difference between the mean amount of money spent by college students on entertainment per month and the mean amount of money spent by college graduates on entertainment per month? We take two samples, which is how you would test this claim. And so we have our data, and notice again, it's two samples. And we're talking about averages here. The only real way we could answer this question is using averages. And so that's why I know, okay, it's going to be either a t-test or a z-test, and it's going to be for two samples. Okay, so I keep reading. It says, assume both populations are normal. We don't really need that here since we have big enough sample sizes, but okay. And have equal variances. Okay, I'll need to know that in a second. Use an alpha or significance level of 10%. Okay, so as I look at this, say, okay, we're comparing two means from two different samples. We don't know the population standard deviations. That means I should use a two-sample t-test. And you won't see any two-sample z-tests in this class because they're very unrealistic. So this would be the default anyway when you're comparing means from two different groups and you have independent samples. All right, so let's look first at the rejection region method, okay? So we'll start with rejection regions. And in both cases, whether I'm doing rejection region or I'm doing a p-value method, I'll need H0 and HA. What I'm going to do is I'm going to call this group 1. I'm going to call this group 2. And so what I could say is we're wondering if there is a difference. So what I could say is we're into a two-tailed test. So this would be mean 1 is not equal to mean 2, and mean 1 is equal to mean 2. All right, so in the rejection region method, what I need to do now is get a test statistic in a critical or rejection region. Now, the formulas in this section get quite complex and tedious to work with. They're not that hard to do mathematically, but they're complex. On the calculator, if you use a two-sample t-test, it will give you all of your information you need as far as setting up your test statistic and your degrees of freedom. So what I'm going to do is get my test statistic from the calculator, and so that's going to give me what I'll use to make my decision. So I go to stat, I go to two-sample t-test, number 4, and then I say, okay, what information do I have for my sample? For sample 1, I have a mean of 105 and a standard deviation of 55 and a sample size of 40. For sample 2, I have a mean of 147, a standard deviation of 66, and a sample size of 45. This is a two-tailed test. And then I'm asked, should I pool or not pool the standard deviation or the variances? And so we're asked here, or we're told here, we have equal variances. And so if I have equal variances, I should say yes to pooling it. What that means is it's going to use the pool estimate when it calculates the test statistic. And then I can go to calculate. So I end up getting a p-value, degrees of freedom, and a t-test statistic. But since I'm doing the rejection region method, what I need is t. And in this case, it's minus 3.164, let's say. Okay, so there's my test statistic. The next thing I need is a critical region or rejection region. And so what I'm going to do is go ahead and draw that over here. Say, okay, here's my t-distribution. And this is a two-tailed test. Alpha is 10%, so we're going to have half of alpha over here and half of alpha over here. And we're going to have a negative t over here and a t over here. And that's going to come from the table. And the mean of the t-distribution is 0. Now on the calculator, I also see that I have degrees of freedom equals 83. Now when I go and I look on my table, I have degrees of freedom 80 for a row and I have degrees of freedom 90 for a row. What you should do in this situation is round down to the nearest that you have. That will be the most conservative move to do. So we're going to use degrees of freedom equal to 80 from the table. And so when I do that, I'm looking for the row degrees of freedom 80. And I'm going over to a two-tailed 0.1, and I get 1.6641. And so this would be negative 1.6641. And so the only thing that's changed, notice, is how H0 and HA look and where I get my p-value or test statistic. Otherwise, the procedure stays the same from previous sections. And now I can say, well, looking at my test statistic here, this is definitely in the rejection region. So I would say I reject H naught. And to answer the question, I would say there is evidence of a difference in the amount spent. Maybe I could say by the two groups, something more specific. So again, the way I made my decision was the same. If I was in the rejection region, I rejected. And so the only thing that changes again is where are you getting your values from? And since this is now 2 samples and we're doing a t-test, it still comes from the t-distribution, but the degrees of freedom formula has changed and the formula for the t-test statistic has changed. So I highly recommend using the calculator instead of calculating these by hand, because you're risking a lot of minor errors if you calculate these by hand. Okay, now the question is, how do I do this using the p-value method? So let's take a look at that. It's still a 2-sample test, still the exact same information, and still the same H naught and HA. Right, so now we want to use the p-value method. So on my calculator output from before, I still have the p-value, and so the p-value here, I'm told, and I'm just reading this right off the calculator, is 0.0022. So a very, very small p-value. This is certainly less than our alpha, which is 10%. So I reject H naught. And then what happens? Since I rejected H naught, I come to the same conclusion as before. Yes, there is evidence there's a difference between the mean amount of money spent between the two groups. So as you can see, you should come to the same conclusion using both methods no matter what. It's all, again, it's about your perspective when you're doing this. Now, the only thing that would change between some other examples is this right here. So if you're told instead not equal variances, or sigma 1 squared doesn't equal sigma 2 squared, then you should not pool. But if you're told equal variances, then pooled is yes. And that's the big thing that will change, because that changes that formula. As you can see in the notes, the formula when it's pooled versus not pooled for the test statistic is very different. And the p-value itself comes from that test statistic.